Good morning and welcome to today's webinar on the latest advancements in Hikrobot's machine vision technology. My name is Dmitry Mikitenko. I work as a pre-sales engineer for Hikrobot, and I am pleased to guide you through this session, where we will explore the latest software and firmware updates for some of our smart cameras. This time, our focus will be on the widely adopted vision sensors, as the most advanced and functionally extensive smart cameras, namely the SC3000 series devices, are not affected by this update. The webinar is designed to provide you with a clear understanding of the key enhancements introduced in our newest firmware series, along with the SCMVS version 3 software update. We will discuss device compatibility and demonstrate a few of the most impactful new features in action. I hope that you have at least some experience with Hikrobot vision sensors and the previous version of SCMVS, as we will not be covering every little detail of the vision sensor capabilities and functionality due to the format limitations and restrictions of this session. So here's a brief overview of our agenda for today. First, we will have a look at the key improvements and enhancements to the updated firmware and software. Then I will tell you about the supported devices and how different firmware versions align with the newest version of SCMVS. And during the next part, I will perform practical demonstration showcasing the advanced capabilities of our flagship vision sensor. And in the end, there will be an opportunity to ask questions and receive answers to gain further insights. We encourage you to stay engaged and share any questions you may have throughout this session. You can post them in the chat. You can post them right here in Zoom. Now, let's begin with in-depth look at our latest firmware series and a CMVS update. So the latest firmware introduces a significant enhancements to a SC3000 series vision sensor, a comprehensive calibration feature. This addition expands the sensor's capability to accurately map image coordinates to real-world physical coordinates, enabling precise positioning and measurement. 3 calibration modes are now available: endpoints calibration and translation rotation calibration. These support TCP and UDP communication for seamless data exchange with the positioning device. Calibration board mode is compatible with checker, circle, and HK type calibration boards. It can be conveniently applied for various distance measurement cases. Image files can be uploaded to the calibration module too, so it is possible to work offline, say with no real image capturing for calibration and analysis. There's a number of parameters available for this module, so it is quite flexible, I would say. Those of you who are who have experience with Vision Master software would find this functionality quite familiar. This update also introduces new algorithm modules that leverage calibration data to enhance precision in various applications, particularly involving positioning, measurement, and robotic integration. Out of this group, I'd like to specifically mention scale transformation. It converts image-based measurements, such as widths and intervals, into precise physical distances based on calibration data. All the other modules mostly will be appreciated by those who integrate vision sensors with industrial robots or similar moving equipment. Two additional modules further extends the sensor's measurement capabilities. One of them is point-to-point measurement. It's a nice tool for dimensional inspection and distance verification in quality control workflows. Combined with scale transformation, it can help you to obtain values in centimeters or maybe millimeters or other metric units Color measure is a tool which can be used in color analysis tasks such as defect detection, material classification, and consistency verification. Those should be pretty straightforward. In this release, several core tools have been enhanced with new functionality that significantly improves flexibility and precision in real-world deployments. The introduction of multiple base image support allows workflows to adapt dynamically to variations in part shapes or product types. This is quite an important feature. With independent fixture templates tied to each image, familiar tools can now operate across varying conditions without configuration or project scheme switching. We will see how it works shortly. Support for multiple regions of interest across key modules, such as classification, code reading, and spot analysis, for example, enables more comprehensive inspections within a single processing step. This reduces cycle time and simplifies configuration for multi-feature parts. We will also see this in action during this session. The OCR module has received substantial improvements, including a built-in deep learning character positioning model. Moreover, 360-degree character recognition is now possible, enabling text extraction even under challenging alignment conditions. We will explore how this can be used in practice a little later. In the calculator module, the expanded set of mathematical functions opens the door to more sophisticated evaluations, requiring geometric analysis or trigonometric transformations, to name a few examples. Finally, enhancements to character comparison allow for greater flexibility in multi-ROI inspections. With new options like string truncation and indexed data subscriptions, the system can now handle more complex logic operations when dealing with variable or compound character strings. And what about a CMVS itself? The CMVS client application has also been significantly upgraded to better support the growing complexity of smart camera deployments. I will quickly mention just the most important changes because there are quite a number of them. With the user interface and appearance revisions, the software now offers a more intuitive and streamlined configuration experience. Quick access to tool settings, customizable layout options, configurable overlays, interactive module settings, tuning help engineers work more efficiently, especially when dealing with high-density tool configurations. Model management functionality is a major improvement when built-in model training capabilities are used. This is relevant for OCR, classification, and object detection scenarios with dataset registration. A CMVS now automatically saves registration-related data, separating annotated image sets from the model itself. This enables users to quickly retrain model based on newly acquired data or choose model with the best performance, a valuable option when updating scheme in production, especially when many vision sensors are in use. The new operator UI builder greatly increases deployment flexibility, particularly in environments with multiple vision sensors. It allows tailored visualization of inspection results and system states, ensuring that monitoring personnel have access to clear, actionable information presented in convenient format. It is possible to introduce modification of certain variables at runtime to influence running solution. During our demonstration part, we will see many of these beautiful features in action. Some of them definitely resemble the functionality available in Vision Master software platform. Again, that's quite a common thing for those who have used that system. And this slide outlines the compatibility between firmware versions and the new SCMVS 3.0 software. In summary, SC3000E and SC3000 devices running earlier firmware versions remain on legacy software and do not require any action. This is because hardware revision is older and there is no way to upgrade them with the new firmware. The same is true for older devices from SC3000 family. However, SC2000E version 3.0, newer SC3000, and all the SC3000X models are fully compatible with SCMVS version 3. For SC3000 and SC3000X devices currently running firmware version 3, a firmware upgrade is advised to make use of all the new features. So as you can see, the latest firmware for SC2000E has version 3, and for SC3000 and SC3000X families, the latest firmware has version 4. That's a kind of difference which you should keep in mind. It's critical to carefully plan the firmware upgrade, as there is no full compatibility between projects created on earlier firmware versions and the new release. This is primarily due to substantial updates made to the base image module. While older projects can be opened after the upgrade, they must be edited and manually validated to ensure correct operation. In addition, projects designed on the new firmware are not backward compatible and cannot be loaded onto devices running earlier firmware version. So this is something to, again, keep in mind and to make sure you carefully upgrade when you decide that you are ready to do it. Of course, this is especially important when you have multiple devices in production and you have maybe a number of schemes or projects running algorithms. Okay, so now we can move on to our practical demonstration. We have 3 scenarios prepared for today. The first one is OCR without fixture. We will see how we can validate text printed on some object without specifying region of interest, with position box enabled and built-in character recognition model. We will retrieve text by parameters and validate with regular expression. For our case, we will use these Coke cans. Hope you can see them. In general, this scenario is applicable when you have an object with no particular features which you can use to make position fixture. So let me show you a CMVS screen now. And I hope you can see it. Okay. So here is our scenario. We can run it. So that's the bottom of our Coke can, and in this Coke can we have a print indicating date and batch, and our goal is to identify that we have date in 2026, I think. So we have a couple of these cans. I hope you can clearly see our setup. All right. And here you can see another one. Should be, yeah, like that, for example. So we can take a look at the solution itself. That's what we have. I will not focus much on camera parameters. Not much has changed here. The only thing I wanted to mention is that in SCMVS, we have settings separated in two categories. One is like base set of settings. This is, I would say, minimally required set, and another one is full set of settings, which is more familiar to those who worked with the previous SCMVS version. You can use this pin icon to always preserve display of the full set of settings. And we are not using any fixture. And here are our tools. So we can look into this OCR tool to see how it works. And we have this position box enabled. And this is our default character detection model, which is supplied along with the camera's firmware. So we did not use, for this case, any self-trained model, but it can be used in case if the recognition quality is not as expected. It is possible and advised to train your own model. It can be done with the Vision Train software package, and we have say tutorial on how to do it. And we are not using any fixtures. We are not using any detection areas. There is an option to apply character filters. There is an option to apply character replace function in case if certain characters for some reason need to be replaced. For example, for scenarios where a recognized string is sent somewhere and we don't want to process it on the other end. So it allows sort of built-in processing capability. We have this parameter. It instructs the algorithm when to try to read flipped string. So it can flip recognized or not recognized, but detected characters 180 degrees first to try to recognize the flipped image of characters. It can speed up algorithm in cases when you expect that most of your text is reversed. Basically, this is how we filter our strings, because we have two strings here. So by setting these parameters, we limit recognition to only the string with the date. And we can test run it right from here. So as you can see, we have recognition with angled text. When the angle is closer to 90 degrees, recognition, at least for this particular font, can be unstable. And apparently for production application, if position of such an item would not be controllable, it is advisable to use a self-trained model. So built-in model maybe would not perform sufficiently well for such a case. And this is how we can actually adjust settings during the test running. That's an interactive setting adjustment. For example, we can disable this. We can disable this parameter, and we can increase this value. So this is how you can, modify these parameters interactively to achieve the results you would expect. Okay, and we can close this project now. I don't want to save it. I want just to show you that we can see overlays here, and we can actually jump to module settings right from this UI. Basically, what we have here, we had here regular expression. This is that's the way to edit it. This is pretty standard thing, and we have year 2026 in the end, and we are validating that the date is in proper format. And here we can see the date. Again, we can interactively test it from here. And we see the date in 2025 will not be accepted. All right, I think it's rather clear with this example, and you can see how this recognition based on built-in character model can be used. And I think we can move on to our next case, which we would like to show you today. That would be use of OCR with with position fixtures. We will use multiple base images, multiple string positions. We will retrieve text by preset fixed ROIs and validate text lines with the OCR tool itself. This can be useful example of how you can use visual inspection in case if you have multiple objects within the same scenario, and as you will see, the text is positioned in it is positioned differently related to fixtures. So I will switch scheme. We have this scheme management UI now. We have here list mode, which actually allows to see a number of parameters for each scheme. This is quite convenient, I would say. And we can switch to this particular scheme. We have tea bags here. They look like these. And we will see them. Let me change the trigger type to off. Let me resave it. Okay. And let me run it. I hope you can see my screen now. Do you see it? Okay, good. So basically what we have here, we are recognizing, for example, on this tea bag, we are recognizing this particular string, and you can compare it. We have another tea bag, for example, and we should be able to recognize string in different position. Let me okay, for example, like this. And we are relying on fixture So in this case, we have quite stable. We should have quite stable text recognition under different angles, because actually with our ROI, the algorithm knows how text is positioned. Maybe it's not so stable because of light, because of print quality, but I would say it should be more or less fine. Yeah, for example, like that. And here we have completely different design. And okay, again, we have pretty stable recognition under different angles. And in case if we have something completely different, we will, of course, have indication that nothing has found and the inspection is failed. Let's see how we have configured this project. This is our base image. And you see we have this multi-reference mode enabled. So we have several base images. And these base images are connected with different templates. We can see template here. It is possible to edit it. I will not do that right now, but you can do it, of course, in your project. And so, okay, this is the template for this image, and that's the template for this image, and that would be the template for this image. And with such a setting, our angle range is from minus 180 degrees to plus 180 degrees. So we are essentially covering 360 degrees rotation of our object. We also have scale range here. I think that's a new feature. And it increases processing time, of course. For our specific case, it wouldn't be impractical to increase it because all of our objects are of the same size. But in case if there's possibility of having, for example, some parts being positioned closer or farther from the vision sensor, it would make sense to increase this range. And with the tools, we have 3 OCR modules, and each module operates on its own base image. You can see these base image specified here, and this way we are instructing, or we are setting each tool to use different fixture. So we are not using position box enable in this case because we want to extract a specific area, and we know where it is located in respect to our fixture. We can have multiple areas. For example, we just drawn a second one. And we are setting this comparison string right in this module. Basically, all the other modules are configured alike. So this is an example of how it's possible to make use of multiple fixtures, say in the same project running in parallel. And of course, our scheme result would be okay, and we can observe this in this pane, in this tab. We can observe it by this OK ratio, and we can observe the recognized string. For example, here. So that's also, I think, something new in this version of SCMVS. And now we can move on to our third example. That's registration classification. We will show how a model trained on board on the camera itself can perform image classification task with multiple ROIs, and how we can use it to evaluate defect position by using only one module. And we will also observe custom UI. As you can see, scheme switching is quite fast. So let me move it a little. We have this circuit board here, and the model was pre-trained. We are evaluating a number of elements on this board. We are evaluating presence of this radiator, and we are evaluating that those microchips are present. This works with the fixture. It should work under many positions. So obviously we have fixture, so it's nothing special. We can go through scheme setting first. And the most interesting part would be this classifier. So as you can see, we have multiple ROIs. That's our model. We will see how it's possible to observe pre-trained models in a moment. And there is a number of built-in, I would say, base models, depending on whether we need to evaluate position of our object, or we just need to evaluate the object itself or its appearance. It is advisable to use different models. We are expecting to get only the first category for each region, and we have multiple regions here. We can draw one more, but we will not do it. We don't need it. So we have multiple regions drawn here. And let me show you what happens if we have any defect. All these additional modules are just for evaluation the class for each region. For example, right here, we are subscribing to a particular region, and we are evaluating what our classifier has detected. So let me strip this radiator, for example. Okay, we can see how scheme will behave if we have a defect in this zone. I have covered one of these microchips with a piece of paper, and we should be able to see that it's not detected anymore as a valid value. Okay, let me remove it. Let me maybe put another defect in place. We can do it right here. So, and what else I wanted to show you? For the model management, we have several models here. And in this window, we can observe data sets. We can rename them. We can actually export them. And we can work with them from this window. Those are our images. And we can add more. We can run training. And here is a list of our models, which we can apply to a specific tool. We can, of course, delete them, and we can export them to move them onto another device. And here we can have our custom layout. So we can see how this custom layout can be used for operators' convenience. So they can observe something important in the parts they are evaluating. All right. This is what you can have in terms of preparing layout. We have a number of elements. We can position them. We can bind them. Again, this is more or less familiar to those who was using Vision Master software platform in the past. There is quite similar functionality over there. And I think that it's about it for our presentation. Now, if you have any questions, I would love to hear them. Thank you for your attention. I hope you found this session useful.